This is a walkthrough of my shell project. We're going to demonstrate 5 things about our program today, one of which is not working properly. First, we're going to demonstrate that the code compiles without warning or error. We are already in the right folder where the code then is, and in order to first compile it to show it doesn't have any error warning, we're going to look at the state of the files in the folder. Using the ls keyword, we're going to see the state of the file in the folders. As you can see, the file currently contains the executable file for the shell. In order to demonstrate that the code compiles without error and warning, we're going to clean it up using the makefile and then recompile it so that you can see it. As such, we're going to use the keyword make clean. This is going to clean it up, and now we don't have the executable my shell file. Then we're going to run it using make. It's going to compile it using a series of flags that's going to check if there's an error and if there's any warning to be raised. As you can see, no warning was raised, the code compiled properly. To emphasize the fact that the code compiled properly with no error, I'm going to show a basic functionality, exit. First, we're going to run the shell, and then we're going to put exit. As you can see, the shell opens and the command exit work as intended. Next, we're going to demonstrate the definition and the redefinition of a variable. First, we're going to open a shell by running the executable file. Then, we're going to assign a value to a variable. The variable we're going to use for today is x. First, we're going to assign the value 1 to x. Next, we're going to print out the value of x. As you can see, the value of x at this point is 1. Next, we're going to redefine the value of x. And then we're going to print it out. As you can see, the value of x is 2. Now, we're going to move on to the third step, which requires to demonstrate an example where a variable is expanded within the definition of another variable. Unfortunately, my code does not consider this and it doesn't work. So when I try to demonstrate this property, for instance, I use x and I assign x to 1, and I assign 1, y to 2, and I try to assign the value z to x, y to x, z to x, if I print z, it just gives me a $sign and x. I have tried this with different way, but unfortunately, the way I encoded the variable assignment doesn't allow for this functionality. Next, I'm going to walk through my code and I'm going to show how it supports the storage of an arbitrary number of variable. And I'm going to explain how I'm choosing to store the variables, the positive and the negative side. First, we're going to exit the shell using the exit command. Then we're going to open the file variable.c, as this is the file that encodes all the functionalities for using a variable, assigning a variable, defining a variable, and so on. Good. Now I shall give you a brief explanation of how this works. First, we begin by creating a structure. I was inspired by this from the linked list example. We create a structure that has two members. One is the name of the variable and the other is the value of the variable. Now, and we name this structure env var. Next, we have a series of static global variables. The first line of the static variable that's assigned to null is a pointer to the structure, the variable structure, this variable structure. Second line is what tracks how many variables are currently stored. The third line tracks the total amount of allocated space in the array. Next, we go into a series of for loop that is within a set variable function. As the name implies, the set variable function is there to set the value to the variable. Now, there are two cases. One, if the variable exists, you redefine it, or if the variable does not exist, you create the variable and assign a value to it. The first for loop does exactly that. The first for loop checks if the variable exists, and if the variable does not exist, if the variable exists, it assigns the value to the variable. It does it for each variable that are currently stored. That's why the envr count is right there. And then we have a condition to print out an error if it fails. Next, we have an if statement. This condition is fairly straightforward. It creates a variable if the variable is not found and assigns a value to it. This is all in all the set value function. Next, we have the function called getVariable. The purpose of this function is quite simple. It dynamically checks the array for a variable with a matching name and returns its value if it's found. If not, it just returns an empty string. Freeing a variable. So the entire point of this function right there is to iterate, is because of one of the conditions given in the assignment description. The condition state, there was a limit. The condition was about the limit of how many variables we can have. No. Like how long the value is stored in the variable we can have, which is 128 characters. And that's the purpose of this. This line right there. It truncates it and prevents it. Now, the free variable, like I was talking about before I got carried away right there, the purpose of the free variable is just to free the memory allocated to the environment variables. So like when you it's just to prevent a memory leak when you complete or exit what is it called, the shelf program. You want to clear and clean the memory so that there's no memory leak. You don't want the memory to be the values to be in a memory in a heap. It might result in some bugs. Next, we're going to go to the last. We're going to go to the last task for today, which is that we're going to demonstrate when we encounter an error and no, we're going to demonstrate. We're going to walk through the code and the case with the expansion. We're going to explain the design. I already did that, but I'm going to re-emphasize it again. I wasn't able to explain properly. I wasn't able to explain properly. Certain. Sorry, just give me a second, okay? Repose. There we go. So, I wasn't able to explain properly a huge chunk of the functionality of the variable function. Now, first we're going to reiterate. The purpose of the last function, free variable, is to free the variable space so that you can use it again. This functionality is what decides the capacity of the variable. Right there. It ensures that there's at most 128 characters. That's all for me today. Thank you so much. I hope you enjoyed it.